No, I get migraines. So I get punched headaches. But I was told to take caffeine. I would put Tylenol as well.
Yeah, like
I hate Twinkies, so I put Twinkies at the bottom. The chemicals are, no, that's right.
Okay. If anyone needs to stay put.
The chemicals are Twinkies can't be good.
Please complete your cryptography.
I still think secrets. And I just rather that.
I'll probably return the previous one and this one at the same time. So now we need to speed up a little bit to have the end of semester a little less stressful and more relaxing. So we are
What's it called?
accelerating right now a little
Oh.
bit. So
Venting.
oh, first I'll collect a little.
I don't know, because I go to Starbucks and I'm like, oh, I want a medium, right? Or a small. Oh, you're going to get a tall. I'm like, stop. No, I want a small pasta. I did tall and then went grande. Yeah.
You want some sauce?
You go. I went to go to Dabs and I get espresso there, and they're like, how like it was dot 3 things. It's like dry, wet.
Doesn't include zero.
There's a third one, and it's no, it's how much foam you want. I don't know. I'm like.
To be a group.
So dry means no
a
foam,
set
wet means
and
soft.
define like then that's it.
Yeah.
Yeah, it's gotta be associated, there's gotta be an identity, there has to be an inverse correct
Yeah, but
Like they all have different like
Maybe it's like a list of how important they are.
something people have never done or heard of.
Okay, here's my question.
Bananas almost personal.
Yeah, I think pack of cigarettes.
And because
And pack of beer.
We learned it
far
probably
too
more
at the bottom.
No.
For, I feel like it being health related because I'm sorry, but pack of cigarettes should
We
be.
didn't learn about. We just learned. Okay, so you.
I think last place cigarettes.
I think this
So
is
there is a chance that
important.
someone will get
I don't think
his or her own work
4 out of 5
for
people
grading.
take bananas.
So then please exchange with the neighbor.
Well,
And
here's
I
the
don't think
question.
people only drink beer.
Maybe Monday.
Oh. Here's the next question: is bananas actually bananas or not?
I
What's
also
the
think
class?
that whoever,
Don't try.
if you,
Yes.
if you want these bananas, that's pack of cigarettes, I don't think they're number 2 banana.
I think that person is just being silly.
Oh, damn.
I know, which made me.
Yeah, right, because like all your backgrounds on Star Wars?
Actually, 14 out of 15 of my backgrounds.
Oh, okay.
There's one that's a pretty long with like water droplets.
Wow. We should have looked on the schedule, what other classes have.
Yeah.
No.
I'm not social experiment class.
I seriously think so. Like
They're
they
recording
have
on
the
us.
chance to record us right now.
Yeah.
Okay, now here's the next question. By law, they can't do that
Okay, we are.
without assigning a waiver.
But we know we're being
No, we're on private.
No, but they
That
can't
is
use,
true.
they can't use the information to get that without assigning a waiver.
Just wait till then.
And then if we assign a waiver, then we're all gonna be like.
No one signs it now.
You have like a school.
Yeah, we do.
So here are the numbers for the grades. How can I surprise you? We will not have the lecture because we will have homework grading, next homework, and discussing of the individual research projects. And when we are done, time will be over. So whatever was planned as the lecture will be rolled over for the Monday, right? And I will try to speed up through this grading and spend more time on the research projects. So the question number 1 is if you were attending class materials, then for creation operator it is lower subdiagonal filled with square roots, right? And the annihilation, you just transpose this one and get the upper subdiagonal filled by this square roots. So main diagonal is 0 in both, and subdiagonal is here. So if you see something like this, give full credit, even if things are a little tense. Analyze obtained matrix elements. Well, if there are right keywords like sub, diagonal, 0, non-zero, also give full credit. Do not be too critical. So for both operators in matrix form, diagonal elements are all zeros. First subdiagonal is non-zero and filled with square roots of index, but it is a lower subdiagonal for creation and upper subdiagonal for annihilation. And all other elements are zeros. The number 3 should be worth of large credit, and we didn't go through the things too much in the class, so it was a challenging thing, and maybe some of this will be covered very soon in additional details. So if you do not see much, or if when completing this homework you had problems about this question number 3, one starts with definition of A dagger and A as linear combination for position and momentum, and then solves it inversely. So just adding and subtracting, and what you are expected to see is that if the creation and annihilation are added together as here's something interesting to show. Are added together, then with the right constant it will be position operator. Here A dagger plus A. And if you have a subtraction of them with imaginary unit factor, it will be momentum operator. So this is most important step, maybe not complicated. Give something a little bit above 10, like 12 if you have this completed. The rest is just plugging in these definitions. So if one wants potential energy, then one just needs the position operator squared, and you multiply the constant, and then have this position squared, and you cannot. You need to keep all 4 terms because order of the operators matters. And if you want to convert position squared into potential energy, you just do definition. Mass frequency squared over 2 times position squared, and then you can identify a little discovery. Then mass disappears, and the potential energy is proportional to Planck constant in frequency, and then there is this linear combination of pairs of operators. So it should be like if you go up to here is +6. Same thing for momentum. You just make square of it. For here I was reading. So p square over 2m. Again, it is interesting that the factor is the same. The negative sign pops up due to imaginary unit, and there is a combination of same pairs of operators, but two middle ones have different signs. And if you add them together, the terms of creation squared and annihilation squared cancel, and we have only creation times annihilation and annihilation times creation. And this minus compensate each other. So, 6. And if you get to this point and do not get to this one, give all but one points.
How do you get from there to the normal definition?
I am not going to show it right now. It is important, it is very serious,
Yeah.
but it will be a lecture instead of grading. But one can derive the conversion from this line to this line by several ways. So it's not affecting grading. If you will cover it again in more detail. So first way, through known commutation of position and momentum. So if you replace these things back in terms of position and momentum, you'll see that their commutation will pop up here, and you know how their commutation is equal to I times h1.
Yeah. I mean,
This is correct, but very, very long and simple.
Right.
Secondly,
Yeah.
express operators in the form of, in matrix form, in Dirac form. Multiply, use snake hunting mice, and identify that they will be, you just come up with a constant term nature. Third way, express these two things in matrix form. Just take these two matrices, multiply them, one order, another order, and see how they differ. And fourth way, look back when we were setting up these operators to represent the Hamiltonian plus constant that appears from the commutation. So in some sense, this total energy equals to this equation was declared at the very beginning. I know it is not very fair. It's
Well,
not
yeah,
derivation, but
So I mean, I could get to that way if I didn't go through the
Yes.
middle one first, but
this is full credit, even if you don't get there. Enough? This one. Probably it's not the most fair. Okay. In order to complete all these questions, this relates to the thing that London was asking. So one is that a dagger, when the plus or dagger sign stays in the second place, will be a dagger a plus 1. So this one is bigger than this one, and this is thing that it will be my responsibility to repeat again and again in the class. But this is the only cornerstone to roll further. The rest is based on this. So if you subtract them in one order or another order, you get either 1 or -1. Right? If you use the commutation between operator of energy and annihilation, you are pulling the factor up front, you are noticing that any operator commutation with a constant will be 0, right? Therefore, we do not have trace of this 1/2 here. And here we have, again, if we are not watching on the screen and only listening, it will be A plus A plus A. So the only difference is the order. And in order to, with purpose, to subtract these two things from each other, we need to have the order of operators with and without dagger to repeat. So we need to swap these two things and pay some price for it. And we can do it. We can swap the order, and the price will be to add a term. And this part is replaced by this one, right? And then we are having this term which repeats. First and second term repeat each other, and the last one has the operator only in the first power, right? It appears from this constant multiplied by this operator. And when these two cancel each other, we have the value of commutation. So please give benefit of the doubt. If there was some, even if the main identity was missed, but a fair attempt to just write operators in different order was committed, give like 60% of credit. Otherwise, we will suffer. Second thing is made similar way, but why do we suffer? Who needs it? Is it just academic practice to learn some non-necessary things? No. The benefit of the thing will be there will be a benefit in the Heisenberg equation of motion for expectation value of position and momentum, where we need to make commutation between Hamiltonian and operator. So it's need for HEOM. So repeat steps 1 to 2 for X. Let's go back. So X is this factor, square root of h bar over 2 m omega times a dagger plus a. So so you add together matrices, you put this factor, h bar over omega, and write square root of 1, square root of 1, square root of 2, square root of 2, square root of 3, square root of 3. So you make it tri-diagonal, where main diagonal is 0, and upper and lower subdiagonal are square roots, and the factor up front is this dimension constant with h bar and 2 and omega h bar. So if you see attempt to this direction, what do you assign 10? For extra credit for potential, and we do not have time to go through the material, but it is expected that second subdiagonal will be non-zero. If you see matrix form where second subdiagonal is non-zero, it is enough to 1, 2, 3, and the rest are zeros to award it with credit. So please go forward with adding together. I'm going to collect and then we'll go through the research projects in the remaining whatever minutes. Any questions?
And look at the second.
Oh, it should be.
Yeah.
This. Right. Are you grading the extra credit? Are you grading the extra credit, or how's that going?
If they attended, they and got something of 2 non-zero lines
Oh.
on each side of this.
Well, many thanks for your commitment to this least pleasant part of the course. It is the reason why most of researchers do either experiment or computation rather than pure theory. So we will have either two or maybe only one who works more because we need to focus on the research projects. And the next homework will be purely computational, MATLAB, and in some sense it will be just repeating what Austin presented in his extra credit presentation, with maybe a little bit more details. So setting up a harmonic oscillator and see how the main observables behave in time.
So we'll use the last round of the software you gave us for the code.
Yep. From now on, we are not going to change the software much. We are going to change only the line that is responsible for the V capital, for the potential. And in free space, it is 0. In barrier, it is a step. If it is oscillator, you just put position minus equilibrium squared and put this h bar frequency over 4. And then you play with initial conditions. And some of you have already discovered that answer depends much on the step of the increment in the discrete space. So if you want to increase precision, you always have this opportunity to have time step smaller and space step smaller. Okay, so tonight, if you elect to come at 5, I will go very in much details, step by step. So basically, I will do this homework myself. So you're invited to join or to watch the recordings if equipment will work. Okay. The goal of the class is to finally serve to interpret or predict outcomes of experiment, observables. So this should be the skills that we accumulate in class should be able to help in understanding what is going on in a range of realistic systems that are being investigated in chemistry. So, wet chemistry lab, characterization lab, and related areas. So I'm going to go over about a dozen possible projects. Right now, you do not need to choose. I'm giving you time to develop your own opinion, to that seeds develop roots. And next week, we will practice democracy with a list where you will either check what you like or write your own subject. So, no action from your side is required, just sit back, lean back, relax, and watch. So, the main hypothesis that we all are going to admit that most of the projects, most of the problems in modern chemistry, physics, and natural sciences can be represented as quantum particle moving in one-dimensional space. This is quite an approximation, but in many cases, all unnecessary degrees of freedom can be traced over. And if you have in mind chemical reaction, these molecules are really hard, many degrees of freedom, but you always I didn't thinking about reaction coordinate, which is one dimension. So we are following the same paradigm. But how does reaction coordinate should look like? It will be, so it is one, maybe two lines in the code, but it will be your creative and challenging part. So in most cases, you will just change one line and the rest will be standard thing. But it is very important step. So no one will change this line instead of you, and as nicely you set it up, the nicer your research will be in the project. So what I'm going to show will be, there will be no colorful high quality pictures. It will be hand scratching of different shapes and explanation where they can be related. So, and you will see a couple of links to YouTube. Those are recordings from students from previous years. So I will distribute these materials, and if you have nothing to do, you can click and watch what others were doing, but it's not necessary. I'm sure you will do better. So, if instead of free space, you have a slope, continuous slope, it is either gravitation or electric field if it acts on electron, right? So this was already done by someone, but if you apply a model, like double wall potential that corresponds to dimer, donor acceptor, or electrode and a molecule in presence of electric field, this will be electrochemistry model of reducing and oxidizing. So first you draw a potential and then you add a constant slope that changes one or other way, and then you see reducing or oxidizing reaction. One option, if you are looking through amorphous materials, conjugated polymers, or amorphous means instead of letting material to slowly crystallize from a mud, you rapidly cool. It has non-crystalline lattice with lots of defects, and these defects can have lower and lower local dips of potentials that will trap charges. No one was selecting it, but it is an opportunity. Another one, if you are looking on the simple harmonic oscillator, and you know several representations of what chemical and physical implementations can be, and instead of one Gaussian, you prepare two, and see whether they will interact with each other. They shouldn't, but when they touch each other, one can observe something attractive. This is related to quantum information and Schrödinger. So, dimer state 1, state 2, or reactant and product, double level potential that you can implement either approximately as square boxes or continuously with fourth order polynomial. By tailoring it as in boxes, you just set this constants and width. If you do polynomial, it is a little harder work, but you can tune the depth and width of these parameters to realistic chemical reaction, to activation barrier, and then see the transition from reactant to product and see how quickly does it go 100% or not. You can find yields. If you recognize the initials AP, then some of this prompt may help you to choose your possible research project, as it may be related to the work that you do for the research. If you have ball and a spring, you can just touch it, make it to ball. But if you have a microscopic, nano-size interatomic distance, and you want to launch it to ball, how do you do it? How do you excite oscillations of a molecule, nuclear motion? Either if you forget about thermal activation, one can apply infrared laser with low frequency, which means periodic oscillations, again, slope, and if you apply slope to harmonic function, it will mean that it will move the equilibrium position to the left and to the right in a harmonic way. So it will be launching, kicking the vibration in the molecule with infrared laser. So this is introduced right now, but there will be a few slides after this. But it is most complicated, most challenging, and it is the maximal level of complication in the course, in the class.
Good selling points.
But you see, some of the previous subjects were never picked by previous generations, but this one, in spite of these 7 points, were chosen. So what do these two intersecting parabolas mean? It means that 60 years ago, Rudolf Marcus got Nobel Prize for it, which tells that even with very simple models that one can solve with pen and paper, one can be rewarded and be helpful to chemical community. And more scientifically, if you have diatomic or something more complicated, we have potential energy as a square potential. But at the very, very first meeting, we discussed that it doesn't need to be square, it can be any shape. So there's potential energy surface as function of interatomic distances for the ground state. But if you change electronic configuration of the molecule, if you excite state, electronic, not vibration, not quantized vibration, but electronic, or a charge is getting transferred from one side of a molecule to another side, it creates dipolar force, dipolar attraction energy, and it contributes a lot to interatomic force. So change of electronic configuration changes potential energy surface. So in ground and excited state, or in neutral and charged transit states, the potential energy surfaces have different curvatures, different shape, and different equilibrium position. So chemical reactions such as charge transfer are also accompanied by nuclear reorganization, by motion of the quantized vibrations which have different potentials. And one can merge it all together and produce some realistic problems. So this area is most competitive, has largest chance to seed into competitive peer review publication in the future. So the rest are more training. This is something solid. Well, examples. What can be different in electronic states? For example, if you take inorganic, right? You will one day.
Yeah.
So, and in inorganic chemistry, it is very frequent motif that you have a metal ion surrounded by
Ligands?
yes. If there would be no chemists around, I would say organic and then say some non-respectful word. Organic stuff around. So respectful word is ligands. And there are molecular orbitals in electronic states corresponding to localized either on metal or on ligands. And when these systems, the organic complexes, experience photoexcitation, then there are possibilities for transitions from orbitals that are localized in metal to orbitals that are localized on ligands, or otherwise, from ligand to metal. They have different optical properties. They have they may induce contraction or complete dissociation of a molecule, and those are types, examples of types of electronic states which will have different potential energy surfaces. So if you are dreaming about metal-organic complexes in your dreams, or if you are already doing some of them in your research, you may select those and understand that it is like neutral and then LMCT state. What are their potential surfaces? Well, I have a graduate student who works on projects like this, and he could help to those who will find it. So it is just one of the examples. So instead of metal organic complex, it is a semiconductor quantum dot made of the one of the most hot topics in today's photovoltaics, so-called lead halide perovskite. And instead of being homogeneous, one lead atom is replaced by transition metal magnesium, and then this system is experiencing several types of excitations, and each of those change the potential energy surfaces. So for some of the projects, you can request help from colleagues. Enough on this. Not boring? Okay. I'm already tired. I'm too excited myself. It's more interesting and more exhausting than pure lecture. So, no one was protesting that we can have intersecting potential energy surfaces for ground and excited state. But one slide before, 2 slides before, 3 slides before, both potentials were, in physics language, conservative. They were returning stuff to the equilibrium position. It is too narrow-sighted. As chemists, you know, sometimes potentials are not returning to anywhere. There are dissociative potentials. We don't have stuff to explode. Or just burning, or just some dissociative reactions, right? So there are reactions such as promoting from ground to excited. You change the potential energy surface so drastically that molecule becomes unstable and bond is broken. There is a person who would be happy to advise and help. Now, done with challenging and not quite coupled, almost coupled, with changing parts and going to most traditional, most typical, and probably the easiest parts of the projects. I do not have much of YouTube's because it was done in the most of the volunteers for these projects were acting in 2011, and I didn't figure out how to record. So, if you just set reaction and product as energy of reactant, energy of product, energy of bearer, width of the bearer, and you do not need to make it conservative on the edges. You can just make short time dynamics, restricting yourself with a time for a single pass, and then depending on the relative energy of reactant and product, you can have either endothermic or exothermic reaction. And if you are having in mind a reaction that you like, that you do for research, or you were just reading science fiction, or something that launches your imagination, you can try your best to either guess, find from literature, or just copy from a textbook these parameters, set them up in the potential, and then the exploration, the only thing that you will be doing, well, not only, but most thing that you will be doing, inspecting how the initial kinetic energy of the wave packet results in the probability of transmitting from one to another side. So, yield of reaction and rate of reaction as function of initial temperature. If the temperature, if kinetic energy is enough to overcome the barrier, the yield and rate will increase. If not, it will either tunnel or nothing will happen. So, most or all individual projects will fit into this product. So, one can imagine some hyperbolic combustion of rocket fuels, or I'm not going to inspect your what is inside your brains, because you can have some very productive and crazy in a positive sense ideas what to model. If the product is higher in energy and activation energy is high, but you can relate it to catalysis reaction where you may induce lowering of the barrier by another degree of freedom by changing the conditions. So you keep the same energy of kinetic energy of initial state, but then you inspect the modification of the height of the barrier, which means that you have edit or not edit a catalyst. There were some examples. By the way, if you look on the examples, they can be as long as 9 minutes. Here in this class, probably we will try to stay within 3 minutes, or we need to request a special day and special time, which I'm not sure that your busy schedule would allow. So tentatively, we will try to oral presentations 3 minutes, unless you contact me personally and majority request that we need a special day. So, I'm not yet over time, right? Yes, 2 minutes, good. So, before now, the reaction coordinate was more related to interatomic nuclear distance or abstract reaction coordinate. When we did start this model, and in the very first options about electrochemistry, the coordinate was true Cartesian position of an atom. So there is a broad range of possible projects where we consider not a reaction coordinate of or in interatomic distances, but true position of electron in Cartesian space with mass of electron not changed. So then we have dips corresponding to ions which attract electron, height or vacuum around where electron doesn't want to sit, and then electron will migrate between ions or distribute between them. And then there is a broad opportunity to first pull the information from quantum chemistry, from atomistic data. And again, I can assign you a helper who will do it for you. So it's not your part of the project. So this can describe thin film. This can describe the interface of thin films of different materials, planar solar cells. This can describe dye-sensitized solar cell or semiconductor and a molecule, pair of donor and acceptor molecule. And here is another helper for semiconductor and dye molecule where charge migrates from substrate to a molecule. So substrate set of atoms here, molecule, maybe deeper potential at other space region. And here just access goes here. If you need to go, that's fine. And most is covered. Fun stuff. Remember at very beginning of the course, you saw visualization of Bohr models. So the code that you're practicing, this one-dimensional propagation, has periodic boundary conditions. So we can consider it as a ring with rotations, probability of staying at a different angle. And then one can identify if the integer number of nodes or non-integer number of nodes will satisfy its Bohr condition, what will happen if it doesn't satisfy. This was done once, but to make it more interesting compared to past, one can add a magnetic field and see like zoom and splitting. If you're looking for something new. Okay, what else? Oh, there is another code that I can share about for nuclear magnetic resonance, spin echo and free induction decay, but it will be different code. If you are just not satisfied with simple assignment as everyone, I can make your life harder. That's it? No, there was one more. Where it is? I have forgotten. There was another fun stuff. Okay, I'll email or include in this. Okay, end of the lecture number 33, which was not a lecture but discussion session. Everyone is welcome to attend evening session on homework number 8. And if your schedule doesn't allow it, then have a nice Veterans Day and see everyone on Monday.
Yeah, it's not too bad. It's gonna be a rough one.
Yeah. Yeah, we have to make sure we have. Yeah.
Did you got an idea what could be of interest for you?
Yeah, well, I mean, out of the ones that you showed right there, the one that probably interests me the most was either the combustion or the one dealing with NMR, just because, well, NMR I've dealt with a lot and kind of have an understanding of how it works, but yeah, there you go. Otherwise, I also have another idea. Like I was kind of asking you about it before, and it was with dealing with electron in a box, and just kind of expanding on that. I don't really know how to explain it in a short amount of time, but could I send you like a proposition
Absolutely.
and
Please.
see if it works with what you're looking for in the research projects?
Yep.
Cool. Then I'll do that at some point.
Okay.
I don't know when, but I have it all in my head. I don't know if it's too, I don't know. simple maybe.
Mhm.
So I might get shut down on that, but it's still dealing with code and like changing up previous code, so.
Yeah, I would be very curious to.
Okay, cool. I'll send it out to you then.